Welcome to this Maths Made Easy video on the geometric series. And what we want to take a look at here first is being able to add the terms and consider the sum of a geometric series for the first n terms. Well, first let's give the formula for the sum to the first n terms, and then we'll actually show how we derive that result. So the formula for the sum of the first n terms is given by this s here with this subscript n, and this is equal to a minus ar to the n, all divided by 1 minus r. So that's the formula, but how do we derive this result? Well, first let's actually consider the sum of a geometric series here for a general series. So Sn here would be equal to a plus a times r plus a times r squared. This is the general sequence here for a geometric series. We take our first term a, and then we keep timesing by the common ratio as we go along. And this will extend all the way up to ar to the n minus 1. Okay, and if you notice, this is our nth term here. Now let's consider this sequence here for Sm, and consider when we times it by r. So we've got r Sm. Okay, and all we need to do here now is take each term and times it by r. And if we times each term by r, then what would we obtain? Well, the first one would be ar, the next one would be ar squared, the next one would be ar cubed, so on and so on. And you can see the pattern now that's forming. And again, this will extend all the way up now to ar to the n, but before ar to the n, we will also have this ar to the n minus 1, followed by ar to the n then. Okay, and that's our very last term there. Now, what would happen here if we took our first series here, Sm, and we subtracted this second series here, this r times Sm? What would we obtain? Well, that gives us Sm minus r Sm, and this is simply going to be equal now to essentially every term cancelling except for 2. So what would be left over here? Well, we've got our a, but there's no a's in this series here for RSM, so the a would remain. We've got an ar here, and if we minus ar, they just cancel. We've got ar squared minus ar squared here, and again, they're just going to cancel. And we can see now that this will keep occurring. Here, our next term would be ar cubed, and we've got an ar cubed here, and everything in between is going to cancel all the way up to this ar to the n minus 1, which will cancel with this ar to the n minus 1. Now we simply get left with here then is a from this Sn minus ar to the n. So we get left with a minus ar to the n. And then we just take a look now at our original formula here for the sum of the first n terms. We can see now that our formula is starting to take shape. We've obtained the same numerator here, a minus ar to the n. So the next step here now is just to take a look at this left hand side. We notice we can factorise this Sn out. So if we factor the Sn out here, what do we obtain? Well, we obtain 1 minus r times Sn, factoring that Sn out here, and this is still equal to the right hand side of a minus ar to the n. And simply, we just want this formula in terms of Sm, so to get that here now, I'm just going to divide through by 1 minus r. So therefore, Sn here is equal to a minus ar to the n divided by 1 minus r there. And that gives us our formula for the sum of a geometric series for its first n terms there. Moving on now to the sum to infinity. So first, if r lies between minus 1 and 1, so if r is between minus 1 and 1, for a geometric progression, or in a geometric progression, then we can sum an infinite number of terms and actually obtain a finite answer. So what's the formula here for the sum to infinity? Well, the formula for the sum to infinity is given by s with this subscript of infinity, and this is equal to a over 1 minus r. So to find the sum to infinity, we only actually need a and r here. So there's two things we can say here. If a series does sum to infinity, then we'd say that's a convergent series. So if the progression or the series sums to infinity, so let's just write this down, if series sums to infinity, then we say this is a convergent series. This is a convergent series. However, if the series does not sum to infinity, so if the series does not sum to infinity, then we'd say this is a divergent series. So if it does not sum to infinity, then we say this is a divergent series. It's just important to note that this restriction here on R is essential for the sum to infinity to hold. Okay, so that concludes this Maths Made Easy video on the geometric series.